started. Okay, so we're going to be graphing, like I said, square root function. Now, what we have here on your paper, this graph that's made is the graph of what we call the parent square root function that is square root of x. So if you were to type square root of x into your calculator, this is the graph that you would get. Now, what we're going to do is we are going to graph on the same grid this square root function, the square root of x plus 3 minus 2. But before we do that, we have to remember what those transformations even mean. Do you guys remember what the plus 3, usually we had parentheses when we did vertex form of quadratics, but the plus 3 next to the x, do you remember what kind of transformation that was? To the left 3. So this square root function is going to go left 3. So we're listing the transformations. And then Kat said I think you probably know the next one then. What's the minus 2 on the outside? What transformation? Yeah, so how are you moving? Down 2, yeah. So this graph is going to go left 3 and down 2. So we have all the points plotted for you, so take your pencil, and we're going to carefully start at this origin here. We're going to move that point left 3 and down 2. Then you're going to make a new point. And this is going to transform this square root function. When you're done, you can connect them. So we're going to be reviewing transformations here. So all that stuff has got to come back. We're going to be moving graphs. We're not going to make you graph without giving you a graph, but then we're going to talk about domain and range again. More of your favorite. So once you've made that, we're going to be talking about, first, how do I find the domain and range of a function from the graph? Now, we have to remember that vocabulary, though. What does domain deal with? What? The x's, the input values, and range deals with the y's. So the first graph, because we actually have 2 graphs on your paper now, that we're going to look at is the one that's already been graphed for you, the parent function. We need to determine what's the domain of the graph for the square root of x. That's where we started. Now, if we said domain was the x's, if I look at this original graph here, I'm coloring it in blue now, what are the possible x's? Where do I start on the left? 0. And where does my graph go to? Forever. So we're going to write this in set builder notation. That means we're going to have an inequality. So this is the one where we're going to have a little curly bracket. Now, usually, we're not going to be too picky about notation in this unit. If you want to do interval notation or set notation, we're just reviewing both of them right now. So I'm going to put an x with the little straight line. Now, how would I write an inequality that says I start at 0 and then I go forever? That's an no, we need an x in our interval, or in our inequality. Yeah, x is greater than or equal to 0. Or you could say x is less than or equal to 0 the other way. You need an x when you do domain. Just like when we write an inequality for range, we have to have a y. So let's talk about the range here. What's the lowest y value for that original graph? 0. Where do the rest of the y values go? Up to infinity. So I'm going to write my range the same way. I'm going to start with a y and write that little fancy line. Now, what inequality would I write that say all the rest of the y's are bigger than 0? Y is greater than or equal to 0. Very good. So that's the domain and range for that very first graph. Now, since I transformed that parent function, the domain and range for the new graph is going to be slightly different. So let's look at domain for this g of x graph. Again, I'm going to start with my x in my curly bracket. I'm just saying I'm looking at the inputs, the x values here. Now, my graph moved to the left. Now, what's the farthest to the left x value? -3. It's right here. And are all the x's bigger or smaller than -3? Bigger. So what inequality should I write here? Greater than or equal to -3. Very good. Now you probably get the idea of what you would write for the range. We do our curly brackets. Now what's my lowest y value? -2, and all the y's are bigger. So I'm going to write y is greater than or equal to -2. That's really bad curly bracket right there. I don't know what it is. Looks like a scribble. So looking at a graph is generally easier to find the domain and range than not having a graph. We're going to review how do I find domain without a graph in a few minutes. Okay? Now, let's look at the bottom, because the bottom is a multiple choice question. We're given a graph, and we need to figure out which one of these equations represents that square root function. So to make this easier, we gave you a spot where we're going to list the transformations that we think have happened so that we can then go over here and identify the correct choice. So what do you think? If I sketch on here, this is our parent square root function that we kind of started with up above. How did I get to that other graph? What do you look like it happened? I did what? Flipped over the x-axis. So I have a flip over the x-axis. All right, that's good. So now my graph is upside down. And then what else looked like it happened? Moved left 4. Okay. Well, what happens to the equation when I flip over the x-axis? Do you remember? There was a negative. Where was the negative? In with the x or in front? In front. Good, good, good. So can I cross any off that don't have a negative in front? C. So C is not right. Nope. So we're down to A, B, and D. Now I need to figure out left 4. Now left, hi Evan, I put something in the folder for you. Left 4. Left and right had symbols that were opposites. So if I'm going left 4, what symbol should I be looking for? Left is going to that way. So what do you think, Connor? A plus sign. And should the plus be under the square, under the square root or outside the square root? I think out is up and down. So I think it's under the square root, which looks like it's going to be what choice? A. So that's the equation. Now, how could you check that if you weren't quite sure? Yeah, plug it into your calculator and see if it looks like that graph. Okay, that's that question. Now, we go to the back. We're going to graph a little bit more. Now this, after I guess we do the domain, I forgot we had to find domain first. So we had figured out how to find domain and range of a square root graph by looking at the picture. And looking at the picture is easier to find the domain and range. But now, if I tell you to find the domain of the square root, when I just give you the equation, we have to think all the way back to Unit 1, back to September this year. That seems like forever ago, doesn't it? A little bit. We're not going to multiply. Now, think about a square root in general. So I'll write up here and then I'll erase it. When I have something under a square root, what kind of numbers can I not generally take the square root of? Negatives. So the number under the square root can't be negative. Can I take the square root of 0? Like, what's the square root of 0? No. That's anything to the 0 power. What's the square root of 0? No. It's not nothing. It's 0. The square root of 0 is 0. So I can take the square root of 0. Can I take the square root of a positive number? Yes, I can take the square root of positive. So I'm allowed to take the square root of 0 and positive numbers, just not negatives. Bless you. So do you remember now what I had to do with the radicand, what's under the square root, and how I found the domain? I said not equal to 0, but close. Greater than or equal to 0. Because I'm saying the number, what x plus 2 represents, has to be bigger than 0, meaning if I look at the number line, numbers bigger than 0 are positive, or equal to 0, because I can take the square root of 0. So now I solved this inequality. So I I would subtract 2 from both sides, and I get x is greater than or equal to -2. That's your domain. Any x value that's -2 or bigger, I can put into that function. Anything smaller than that is going to give me a negative. Okay? That's it. Do you kind of remember doing that long, long time ago? Kind of, vaguely. We're going to get good at it again. All right, so let's look at B. I'll do B with you, and then, actually, no, I'll do C with you, and then we'll do B on our own. Let's do C. So I'm going to take 8 minus 2x greater than or equal to 0. It's always greater than or equal. If you don't have that symbol, it's incorrect. Now, where would you start to solve C? Minus 8. All right, that works. Minus 8, minus 8. Cross this off, so I get -2x is greater than or equal to -8. And then how do I get x by itself? Divide by -2. And when you do that, you should have a warning sign going off in your head. Flip the sign because you divided by a negative. Awesome. We got to remember those little things from a long time ago here. So x is less than or equal to 4 is the domain. All right, I want you to try B on your own. Okay, go. I'll write it up on the board just so it's here for the video. And then when you're done, you can check and see if you got the right steps. So I want everyone to be trying this quietly. Luke and Robbie.
What?
I said, let's try this quietly.
I'm sorry, his hands are just really soft.
He must use lotion.
I really want to. Look, he's got it right here. Look at that.
Yeah.
All organic too. This explains everything.
That's so special. All right, check your domain on the board. Gentlemen, check your domain on the board once you're finished. See if you get the right answer. I'm putting this on the video for everyone to hear, Luke. I am recording, yeah.
That's why I said your whole name.
It's okay. We good? Any questions on finding domain? Really ask. If not, I can talk through it. Okay. Now, we're to the point. Now, are we just passing the lotion around today? You all just want nice soft hands?
That doesn't sound weird.
It doesn't sound weird at all, yes. Okay, now let's get to graphing. The whole point of this. We're talking about domain today and graphing. Now, this setup should look familiar to you. We graphed parabolas in our transformations unit doing the same thing, multi-step graphing. So what we're going to do here, ladies and gentlemen, we're going to have an equation given to you. So now I have 3 times the square root of x minus 4. We're going to list the transformations that are happening above the graphs. We're going to do each transformation one by one on the graphs and then state the domain and range. Okay? So we gave you the parent function. So this will help you figure out what points you're plotting. Will you guys stop?
Will that be the same parent function every single time?
I can't hear you. I'm sorry?
Will that be the same parent function every single time?
Yes, same parent function. Always the square root of x. So let's start. Remember, we always worked left to right when I listed transformations. What does a 3 out in front tell me what the transformation is going to be?
It's going to be 3 times 1. Dilation.
Kind of like dilation. We didn't call it a dilation, though.
It was not actually like
A vertical stretch. So here, our first transformation is a vertical stretch by how much? 3. Good, so that's going to be our first transformation. Then let's see if there's another one. I go inside the parentheses. It says x minus 4. What does minus 4 in the parentheses mean? Right 4. So now we're going to move our graph right 4. All right, very good. Now, we did multi-step graphing here. Do I have any other one? I have 3 grids here, but do I have another transformation? No, just the 2. So when I vertically stretch by 4, what am I going to change from this parent function? Multiply by 3, Carter says. So 0, does 0 change when I multiply it by 3?
Definitely not.
Nope, so that point stays the same. It stays at 0, 0. Then I have the point 1, 1 here. What is the y value of 1 multiplied by 3? 3. So I'm going to be at a point at 1, 3 now. Then I have 4, 2. Which number do I multiply by 3? The x or the y? The y. The y, vertical. So 2 times 3 is?
6.
Yep, so I'm at 4, 6 now. And then 9, 3. It's going to be at 9, 9, yes. So way up here. And those are all my points, so I'm going to connect those. And that's when I just stretch the graph vertically by 3. Now I'm going to take that graph, the next one's a little easier, and I'm going to move it to the right 4 units. So I'm going to start at 0, 0, I move it to the right 1, 2, 3, 4. Then the point at 1, 3 there, I'm going to move it 1, 2, 3, 4 to the right. Right, so every point is now moving to the right 4. So 4, 6, 1, 2, 3, 4. And it doesn't look like I can fit any more points on my grid. That's going to be what I have. It's a bummer. So let's talk about domain and range. I'm looking at this final graph right here to do domain and range. We said before that domain was x values and range was y values. Now, do you want to write the domain and range this time in set notation or interval notation? All right, interval notation. We'll do that. So when I look at this graph, where do I start on the left? Where's the farthest to the left this graph goes? 4. So I'm going to start with 4. Now, does that get a parenthesis or a bracket? A bracket, comma, and how far does the graph go to the right? Forever, infinity. So that is our domain. I like interval notation. Now, range. What would be the interval here? What's the lowest y value? 0. Yeah, and that gets a, there's a point there. A bracket, comma, guys, infinity, with a parenthesis. So that's your domain and that's your range. All right, we have 2 more and that's it, and then we're done. So let's do 2 more graphs. Let's review these transformations, and then we'll let you have a few minutes to work. Okay? So the second graph, negative 1/2 square root of x plus 6. First, let's list all the transformations. What's the negative out in front?
Over the left, over the left.
X-axis. So reflect over x-axis. Bless you. Reflect over the x-axis. And then the 1/2. Condense. Vertical compression by 1/2. And then plus 6. Oh, nope, it's on the outside of the print.
Down 6.
Down. No.
Up 6.
Up 6.
I think so, Jake.
We had to get there eventually. Up 6.
Come on, 6.
All right. Now, let's be careful with this. Now, I'm going to take my first graph, and I'm going to take all the original points and reflect them over the x-axis. So 0, 0, when I reflect it over the x, does it change?
No.
Nope, so it stays at 0, 0. Guys, calm down. At 1, 1, when I flip it over the axis, it goes to 1, negative 1. Then 4, 2 will be at 4, negative 2. And 9, 3 will be at 9, negative 3. So it should just look like you just flipped your graph upside down. Now, I want you to be careful with the next one, the vertical compression by 1/2. Because you're going to be multiplying the y values by 1/2. So they're going to be getting smaller. So it's actually going to kind of smush this graph and make it a little bit flatter. Okay? 0, 0. Will that change when I multiply by 1/2?
No.
Nope. So that stays the same. Now, where will 1, negative 1 go when I multiply by 1/2? 1, negative 1/2. So it's just a little bit down. So you just need to be accurate and careful. Okay. 4, negative 2 will now be at 4, negative 1. And 9, negative 3 will be at 9, negative 1.5. So you should see that it's actually a very mild, it's very slow growing now, but it looks almost linear, but it's not. It's just because of our grid is really small. Now the last one, up 6, should be very easy. I take all those points I just plotted and I move them up 6 units. So 0, 0 will now be at 0, 6. 1, negative 1/2 will be at 1, 5.5. 4, negative 1 will be at 4, 5, yep. And 9, negative 1.5 will be at 9, 4.5. So there's our carefully plotted graph. Now we're going to do the same thing with domain and range here. All right, domain. When I look at the final graph, what's the farthest to the left that this graph goes? 0, and it goes to infinity. Very good. And then the range. What's the lowest? We start on the bottom. No. It goes, there's an arrow. It goes forever. Negative infinity. And it goes up to 6 with a bracket. Yeah, that was a little backwards. Okay. Last one here. Oh, new reflections and transformations here. 2 square root of negative x minus 2. If you want to work ahead of me and see what you can do, that's fine. Then there's practice on the last page you can start. If you want to stick with me, go ahead. The practice on the last page is only 4 questions, so if you get done early, just start with that. Now, what does the 2 in front represent?
Vertical stretch.
Vertical stretch by 2. Vertical stretch by 2. What about the negative in parentheses? Reflect over the y-axis. Good. Reflect over the y-axis. And then the negative 2, it's outside the square root. It's outside, so it's down 2. Yeah, we got to remember all those. So again, if you want to work ahead of me and then start the practice, that's fine. You can just check your answer when I'm done. If you want to stick with me, that's cool too. So vertical stretch by 2 is we're back to multiplying. So I'm going to start by multiplying all these points, all their y values by 2. My graph should get taller. So we'll be at 0, 0, 1, 2, 4, 4, and 9, 6. So the vertical stretches are a little easier to look at since they make everything bigger than the compression. Now when I reflect over the y-axis, that means everything's going to flip over the vertical y-axis. So it's now going to be pointing to the left instead of to the right. So my 0, 0 still doesn't move when I reflect it. The 1, 2 is now at negative 1, 2. Negative 4, positive 4. And negative 9, positive 6. So now my graph is just going the other way. When I reflect over the y-axis, and then down 2 should be really easy. All right, we now take those points and just move them down. Up and down, left, right are the easiest ones. So I'll go down 2 for all of these. There we go. And we're going to find our domain and range here, and then we'll be all set. Any questions on how I made any of those graphs? I kind of assumed you were kind of working through it, and then we could check as we go. Now, when I look at the graph in red up here, my domain on the left, where do I start? Since there's an arrow, negative infinity domain. And my graph goes until what x value? 0. Stop being silly. Give me the right answer so you guys know it. Range. Where's the bottom of my graph? Negative 2. And it goes until infinity. There you go.
That's like a curve. Yeah.
Now, your job the rest of the period is to, let's see, I'll pause the video since they don't need to know